Well, hello there! I hope you're having an amazing day, my friend, because today, as you probably already know, we are going to be talking about character methods that we have at our disposal, but in real life. So the moment has come not to just theory craft, it's time to actually apply all the knowledge we acquired in reality, which is the most important part, right? So basically, our Visual Studio Code is going to be our home in this video. There is only one thing I want to say: Christmas! All the theory crafting from the previous video means nothing if you do not know how to apply it in real life and in practice, which is why this video was actually created. So we would learn how to apply all the knowledge we have mastered in the previous video and to use all that to solve all the problems that we may encounter in our developer lives. And that is why this video actually exists and is just waiting for you to attach it to your Rust belt of skills. Of course, in this video we will be going through each and every method that we covered in the previous one by one, in the same exact order as in previous video, which is why if you did not see that previous video, I highly recommend you to do so, because even though theoretical, it will give you a lot of explanations and insights which are necessary to be mastered at this point, so you will get the most benefit out of this video. So here is the link to that video. And now that you are aware of all the things that you need to know and you have mastered the previous video, it's time to start getting our hands dirty with some character methods in Rust. To the Visual Studio Code, Alfred. Welcome, my dear friends, to the Visual Studio Code. We finally made it here. In the last video we did not pay any attention to our Visual Studio codes, so right now we have to make it up and to spend a lot of time here. So that's exactly what we will do. Let's start from the first method that we covered in the previous video, and yes, I'm looking at you from U32 method because you're the first one to go. And if you remember, the whole purpose of this method is to actually enable us to convert a number, which is of type U32, into a character. As you can see right here on the screen, I have prepared quite a few examples for this video, but we will be starting things off from the first one, which is going to be dedicated to converting a decimal number into a character. The notation you can see on the screen right now might not look so familiar and understandable to you right now, because we were not using it up to this point, because this is a notation for invoking methods in Rust. As you can see, we have char keyword on the right side from our equals operator, which means it's not defining the data type for the variable, it's actually going to be a way for us to specify which set of methods we want to be using. And because we want to be working with characters, that is why we specify char as a data type from which we want to be listing all the available methods. And when we start searching, we can see that we do have from U32 at our disposal. So we will select it, and after that we need to specify the value, so the U32 value, which we want to convert into a character. So I'm going to specify this number. I don't know, for some reason I just like this number, I don't know why. And after that, you can see that we have another chained method here. It's called unwrap. And this method I will not cover right now because it's an extremely important topic in Rust, which is why we will dedicate probably entire video just to this method, because it is one of the methods that allow us to say that Rust is a really safe language. So basically, you should look at this method as one of the Rust's safety methods. So one of the methods that provide us with safety in Rust. That's all for now, but I will extend on this very thoroughly in future. Do not worry about it. So basically right now there is only one thing left, and that is to run our program, because I hope that we managed to cover each part of our expression here, so you should be able to understand what we are doing, and that is why I want to run the program and see what we get as a result. And when we do that, we get a heart. And this heart is not here without a purpose. It is here for all of you wonderful people who are supporting me and enjoying these videos, and this is just my way of saying thank you to you guys. Because it really does mean a lot to know that you got support from such a wonderful audience. One more thing that I want to cover here is the fact that we can convert any number system value that is of type U32 into a character. So let us test converting a hexadecimal value into a character, just to show you that you can do it. So let me add this exact value and nothing more. Let's just execute the code and we get 2 hearts, because 1 heart is not enough for you guys. So yeah, I just wanted to show you that quickly, and right now we can continue our discussion. If you were wondering how can you convert a character into a number of type U32, and we did not mention any methods for doing this in the previous video, so I just wanted to clarify it very quickly. So the procedure for converting characters into numbers is way simpler than the other way around, which is why we do not need a specific method for it. Why is that the case? Well, just think about the fact that any character that exists can fit in U32 value. So no character that you can produce, no character that exists right now can exceed the limitations of U32 data type. While in the opposite direction, you do remember that we do have some ranges of values that are invalid. So there are some numbers which when converted to characters will do not result in anything meaningful. We will get that character with question mark, if you remember from the previous video. Which is why converting characters into numbers can be very simple, and we can just use as keyword. So if you take a look at the example here, you can see that we have a very simple notation, and I'm just printing out the value, the numeric value of this special emoji. And when I do that, we do get a number, as you can see here. So that is exactly what we expected. Ta-da! Our first method for working with characters was successfully mastered. I hope so, at least it was successfully mastered. But yeah, we did that. So right now we can continue our journey on mastering all the other methods. Of course, I'll try to do it in a bit quicker fashion because we wasted a lot of time on the previous one, but we had to explain some basic things before we can continue. So I have only one question for you. Are you ready to jump into discussion about is ASCII method? Because that's the one that is next on our list. You know, the one where we are checking if a character is within ASCII range of characters or not. Does it sound familiar? I thought so. Let's get right into it. So we're back in our Visual Studio Code and we're ready and eager to master is ASCII method. So to do this, I have prepared 2 variables which are named in a very intuitive way, so you will probably know what the results are going to be. So the first one is going to contain an ASCII character, so something that we know for a fact is an ASCII character. And in the second variable, we will add something that is not an ASCII character. So if you go to the video about characters in general, and take a look at the last part where we were using that for loop to print all the ASCII characters, you will see that there is no such emoji printed there. So basically that means that it is not an ASCII character. One more thing that I want you to note here is the fact that our notation is a bit different from the one from the previous example. So here we are not using char data type and then invoking method from it. We are using our character variable and then calling this method on it. So we are using our first variable and then dot is ASCII method is invoked on that variable, which basically means that the ASCII is going to check if this particular variable contains a value which is an ASCII character. It's as simple as that. So when we run our code, we get expected results. The first one is, so we get true as a result because it is an ASCII character, and for the second one we get false because it is not an ASCII character. Now that was short and sweet, I have to say. So right now it's time to extend things a bit further with those very useful methods that we will be using a lot in our careers. I'm talking about methods that you might remember as is whitespace, is uppercase, is lowercase, is digit, and is alphabetic. So if you do remember those, let's get back to our Visual Studio Code and master them. Again, we're back in our Visual Studio Code, and now we are going to be starting our discussion about isWhitespace method. We have two variables, we are using isWhitespace method on them, and as a result we get, ta-da, expected stuff. So in the first variable we have a whitespace, and in our second variable we do not have a whitespace, and our methods are going to prove that we are right and we get true in the first variable and false for the second variable. So yeah, that's basically all we wanted to prove here. Which allows us to jump right to our next methods, which are is uppercase and is lowercase. So here I wanted to prepare a very simple examples. We have two variables, and for each of those variables we are printing three things. So we are printing the value within the variable, we are printing the result of is uppercase, and we are printing the result from the method is lowercase. And when we do that, we will get the expected results. So for the first variable we have a lowercase letter a, and for the method is uppercase we get false because lowercase letter a is not uppercase, and for the method is lowercase we get true because lowercase letter a is lowercase letter. And in our second example we have uppercase letter, which means that for is uppercase we get true, and for is lowercase we get false. Ta-da! Very simple. Great job! We are done and we can continue with is alphabetic and is digit methods. So in this scenario, I wanted to introduce four things that we are going to be printing. The first one is character itself, the second one is going to be is alphabetic, the third one is going to be is digit, but for the number system that is decimal, so the radix is going to be 10, and the fourth one is going to be is digit again, but we will be using hexadecimal system, which means that our radix is going to be 16. So when I run the example here, we will get quite a wordy result. But everything is logical here. Let me show you. For a letter A, we get the following results. So for the is alphabetic, we get true because letter A is a letter, which makes it alphabetic. When it comes to the decimal is digit method, so with the radix of 10, we get a false because letter A is not a valid digit in the decimal number system. And in the fourth one, so basically when we call is digit method but with the base 16, so for the hexadecimal number system, we get true again, which might seem weird at first, but when you think about it, it's not, because hexadecimal system contains letter A, which actually has a value 10. So it's basically just as we would write number 10 here. So that is a digit, which makes it give us true as a result. And in our second variable we have number 6, and when we go through all the same procedures, we get false for is alphabetic because it's not a letter, we get true for is digit with the number 10 as the radix, because it is a part of decimal number system, and for the hexadecimal system we again have number 6 as a valid value, which gives us true as a result as well. And yeah, congratulations, that's all. Also, one more thing, have in mind that if I were to use, for example, letter X as a value, in our character here, as a third example, let's say, we would get false for both decimal and hexadecimal methods that are trying to see if it is a digit, because letter X does not have a value in both of those number systems, which is why we would get false in both cases. Makes sense, right? Of course, if you have any questions or concerns, please let me know in the comment section of this video, and I'll gladly try to help you out and explain as much as I can to make your lives easier. Congratulations! You successfully mastered those methods! It's time to start talking about the transformational methods, which we discussed in the previous video, and right now we're going to see them in action. I'm talking about 2 uppercase, 2 lowercase and 2-digit methods. I don't know if you prefer Autobots or Decepticons, but I'm not talking about those transformations. I'm talking about character transformations. Lame! I know, I loved Transformer movies. What can I say? It's my fault. Sorry about that. And once again, welcome back. It is time to talk about transforming our characters. So, the first method we will be covering is going to be 2 lowercase. And to give you a good explanation how things work, I need 3 examples here. So, the first one is going to be uppercase letter, the second one is going to be lowercase letter, and the third one is going to be a digit. So, when we use 2 lowercase method on these values, we will get the following. So for the first scenario, where we have an uppercase letter, we will get the lowercase version of that letter, that same letter. In the second example, where we have a lowercase letter, we will get that exactly same letter, because there is no lowercase letter, and which is why we will get the lowercase letter, which is the one that we initially had. So, nothing confusing here. And finally, when we apply this method on a digit or any special character, we would not change it in any way. So, yeah, it's very simple. Now on to uppercase method, which works exactly the same as the lowercase method. So when we uncomment the code and examples that we have here and run the code, you will see that we get expected results. So for the case where we have an uppercase letter, we do not change it in any way. When we have lowercase letter, we just return its uppercase counterpart, and that is basically it. Everything else is very simple, so there are no additional troubles that we have to go through. Okay, our final part that we need to cover is dedicated to 2-digit method. And for this method, if you remember, we need to specify the radix again. So the same scenario as for is-digit method. Because as you already know, it makes sense to specify it, so our compiler would know exactly what we want it to do. And when we uncomment our examples here and run our code, we will get an error. Because when you take a look, it makes sense to get an error, because you cannot convert a letter into a valid number. Because in our first example, we are trying to convert a letter A into a hexadecimal value, which is completely fine, because that's exactly what we can do, but that's not the part that's making our code to blow up. It's one line above that one, the one where we are trying to convert letter A into a decimal number. So letter A does not have a value in a decimal number system, which is why we get an error. And if I comment this part here, we will still get an error, because in our next example we are trying to convert letter X into its both decimal and hexadecimal counterparts, and there is no value that is valid for decimal or hexadecimal number systems that is represented by letter X. So this is going to throw an error as well. And when I comment this out as well, and I run our code again, we will get everything working, because number 8 is a valid value for both number systems that we are using here, and that is why everything gets converted properly. Everything seems like a fairy tale right now. Everything works perfectly fine, everything is fine and dandy, and yeah, that's it. We managed to cover all the methods from the previous video that we covered in theory, but this time we did it in practice. So right now you have the full package, my friend. And now, dear friends, we are done with our talk about character methods. At least the basic ones. Of course, there is a whole bunch of other character methods that we did not cover in these videos, which you can master on your own. But right now, you should have a solid background and you should have enough information to be able to go through the documentation and figure everything out on your own, which is the most important stuff, to be completely honest. So I will attach the link to the documentation about character methods in the description of this video, so if you're interested in that, please do find it. So I really hope that you enjoyed this video and that you found it useful, and if you did, I would like to invite you and kindly ask you to subscribe to this channel and to like this video, because it would help out a lot both me and the channel to grow and spread the value about Rust programming language to as many people as possible. And for this, I have to say thank you in advance, because it really means a lot. In our next video, we are going to be jumping to another computer science topic. We will be talking about memory allocation for different data types in Rust. So basically, you will learn some very low-level stuff in the next video. So if that sounds interesting and you would like to become a really good developer who understands how things work under the hood, I invite you to the next video. And right now, there is nothing else to say except I wish you an amazing day, and until the next video, goodbye.